Good evening, wonderful seventh graders. Today I want to teach you how to rotate a figure in the coordinate plane. So you know the drill. Make that the title on the next page in your math notebook. That page, close it. This is a tricky one. Well, this is a tricky one and then a really not tricky one. So mark that page, close it up, and be real ready. So we've been talking about transformations for a bit now, and we have so far talked about translations and reflections. And today we are going to add rotations. This is what they look like. I know you've seen them in that intro video. They are by far the trickiest one we've had yet. They involve rotating each point like it's sort of attached to the hand on a clock, let's say, as that clock rotates around like that's the center of the clock. That's kind of how they work. So it's going to follow that path like it's on a circle or kind of on like the arm of a clock that moves. And then like the top point is on the longer arm of the clock. So it kind of moves like that. Didn't draw that one as well, but kind of see the point, right? They're a little tricky to get the hang of how to draw and all that. So they are, first of all, you're going to need to know some words you may have heard before. Rotations are clockwise or counterclockwise first. So clockwise literally means just like the rotation is in the direction that the hands on a clock go. Counterclockwise means it's in the other direction, not the direction that the hands on a clock go. So that's what it does look like. So this one back here that I had shown you before, this is a counterclockwise rotation because it's moving sort of not the direction the hands on a clock go. So if those words weren't familiar to you. And so also a thing to know, in addition to clockwise and counterclockwise, they usually come in 90-degree increments. So we either usually rotate something 90 degrees or 180 degrees, or 90 more degrees is 270 degrees here. And then 360, we don't really do that much, but if we did, it would just be back to where it was before. So counterclockwise rotation similar, 90, 180 in the other direction, and 270 in the other direction. And you may even notice like a counterclockwise rotation that's 90 degrees is the same as a clockwise rotation that's 270. You still end up here either way, whether you go 90 degrees that way or 270 the other way. So they end up being the same. And then the 180s are the same too. So there's not actually that many different ones. It's just sort of how it's talked about. So there's a sort of hard way to do rotations on the coordinate plane first. So let me show it to you. So here's a trapezoid, and I'm going to show you how to do it. So I'm going to rotate the figure 90 degrees and 180 degrees. And I'm going to go counterclockwise. So counterclockwise is this way. So the figure's going to kind of go as though it's connected to the hand of a clock, that direction. All right, here's how we do it. I'm going to go one point at a time and kind of show you how this works. So I want you to notice, if I start with this point closest to the origin here, to get to the, or if I drew its clock hand, so to speak, its rotation arm, sort of like that. To get to the origin, it goes down one and over two, kind of to get to the origin. That's how that clocking works. It's down one, over two. So if I make that same clock hand at a 90-degree angle, and I make it the same as in my 90-degree angle here, and I make it the same length, it would go, instead of going one down, two to the left, it would go one to the left and two up, kind of like that. And if I think of it that way, I end up with the same length arm and a 90-degree angle. So the new point will be here. And I'm going to erase all this business I used to get it there. Okay, I know that's a lot, so watch me do another one or two. I'll change colors to make it help too. So let's do this one next. So this one, again, I think of it like it's on the arm of a clock and it's going to rotate 90 degrees that way, but to get just the right spot, its clock arm to get to the origin, you go down 4 and over 1. So when I get over here, I'm going to kind of do the opposite of that. I'm still going to do 1 and 4. I just have to make myself a 90-degree angle. It's going to look kind of like that to get my 90-degree angle. So instead of going 4 this way and 1 this way, the 90-degree angle is going to be made by going 4 this way and 1 this way. And if I do that, I get that 90-degree angle and I get the same length arm. So it's like it went like that. Tricky to do, takes some like getting used to. Let me kind of back some things out there so I can leave it and erase it. And I'll do one more before I show you the other way to do this too. So I'll do a red one, so same deal. How about this point here way up there? So to make its rotation arm, I would have to go down 4 and over 5. So to make its rotation arm, I'm going to go over 4 and up 5. Over 4 and up 5. If I do that, again, little to get used to, it's going to make a 90-degree angle and give me the same length away from the origin. And that's how you do it. And so there's those, and there'd be one more point. I'll go ahead and do it too. I'll just kind of try to do it kind of fast so you don't have to sit and watch me do the same thing forever. So which one haven't I done? This one. So it's down 1 over 4. So the reflection point is going to be over 1 up 4. And if you do that, you get the rotated figure. So you may want to watch that again. I know that's kind of weird. It's like you reverse it. If you go down 3 and over 6, then the other one you're going to go over 3 and up 6. And that's how you do it. You just kind of like reverse those things. You kind of get the hang of it after a little practice. The reason I'm not going to dwell on it too much is there's also a very easy shortcut to doing this, like a very easy shortcut. I want you to know how this works, but frankly, there's a real shortcut, and here it is. If you have the figure and it's on paper and you're on the plane, this only works if you have the figure drawn. If somebody's like, hey, the point is here, where would it be? But if you see the figure and it's drawn and you want to rotate it 90 degrees counterclockwise, here's all you do. Ready? You just rotate your paper 90 degrees counterclockwise, and you got it. That's it. You'll notice that comes out exactly the same as the one I drew here. The only thing you'd have to do if you do that, you kind of have to redo your coordinates because you'll notice my positive and negative numbers are kind of in the wrong place. So if you wanted to find the coordinates, like the negatives are here, I'd have to like redo this 1, 2, 3, 4, 5, and this would be -1, -2. You might have to redo some work on your coordinates, but really, literally, all you have to do is rotate your paper. Crazy, right? All right. Let's do one together. So in your math notebook, pause and do this on some graph paper. We'll rotate this triangle. I've noticed I didn't do the last one 90 degrees, so we'll just do this 90 and I'll make another video with how to do 180. I'll make kind of like a part two. First, and then I'll do a 180 next. So here is the deal. So to rotate this 90 degrees clockwise, so clockwise is this way. Let's start with point A. So to get point A to the origin, I need its arm to be like that. And clockwise, I'm going to go over here. So I'm going to end up over there somewhere, 90 degrees. I want to make a 90-degree angle from this that I drew here. But to make sure it's perfectly 90, here's how you do it. I went up 3 over 2. Up 3 over 2. So to make its rotated point, I'm going to go over 3 and down 2. And new point A or A prime is going to be there. Up 3 over 2 becomes over 3 down 2. So and if I do that, if I were to connect them, you'll see I end up with a 90-degree angle, and I end up with the same length arm. And then I got to erase all the business to get there because I don't have room to do that a whole bunch of times. But that's the trick to do it. So then B, same deal, I'll change to maybe blue. So B, to get to the origin, I've got to go up 4 and over 5. So the new point B, I'm going to go over 4 and down 5. And when I do that, I'll end up right there, B prime. Okay. And C last. Do C in red. So C, I've got to go up 4 over 2. So to get the new C, I'd go over 4 and down 2. C prime is going to be right there. When I do, I've got a nice rotated version of that triangle. Like that. It's still congruent, worth noting. Same triangle, rotated. I would make a note too. That's how you do it the traditional way, the old-fashioned way, where you literally like figure out what happens to the point. Looks like I did it just right. I literally rotated it 90 degrees that way in the direction of the clock. But the other thing you can do, you can just make a note of this. You just say like, can also just turn your paper 90 degrees clockwise. I think I have another slide for that I'll do next. Like that's all you have to do. Like that's another way to, I don't have another slide. So another way to do it, and you'll even see my new triangle end up right where the one I drew is because it's going to stay there. If I just turn this 90 degrees, like there you go. Oh, so close. Must not be quite a square image. Slightly rectangular. Oh well, that would have been cool if it ended up like right on it. I mean, it did. I did it right. It's just not, this figure slightly off scale. And that's how you do it, y'all. That's how you rotate a figure 90 degrees. I'll do a quick follow-up video to this, a part B, where I talk about rotating stuff 180 degrees. It works pretty much the same way. So stay tuned. There will be a part B. But that's how you do 90, and that should get you a pretty good start.